Assalamualaikum and very good afternoon to all of you. Welcome back to BAA4273, the Earthquake and Engineering class. This is the second part of the video. As I mentioned to you that I will present about the design response spectrum. Alright, the design response spectrum is a plot of the peak or steady state response, which represent the displacement, velocity or acceleration of a series of oscillators of varying natural frequency that are forced into motions by the same base vibration of shock. It is initiated by Ir-Wan in 1932. Okay, it provides convenient means to summarize the peak response of all possible linear single degree of freedom systems to a particular component of ground motions. The application is to the development of lateral force requirements of building codes, and it converts the time history records to response spectrum. Okay, so this one, okay, this is the time history record. As I mentioned in the previous video, the displacement against time, velocity against time, and then the acceleration against the time, and then we convert it to the in terms of response spectrum. Okay, we use available recorded time history from a real earthquake, and then by using a bit, for my opinion, complicated equations, we convert the design response, the time history record, either acceleration, velocity, or displacement, we convert to this shape of design response spectrum. Okay, we choose the ground motion records of similar size, magnitude, distance from fault mechanism, soil condition, travel path of seismic wave, and then we convert up to this shape before we find the mean value of this shape. Okay, this is the standard shape of design response spectrum. This is the period of vibrations, and this is the spectral accelerations. Okay, for the design, we need an envelope, therefore we consider the mean value, as I mentioned before. Okay, this is the elastic or design response spectrum based on the Eurocode 8. This is the standard shape. We have the S, okay, we have the TB, TC, and the TD. Okay, this the value will be is given based on the soil type. Okay, this is the type 1 elastic response spectra, and this is the type 2. Based on the table 3.2 in Eurocode 2, they consider 5 types of soil, which is A, B, C, D, and E. Okay. This you can refer to Eurocode. This is the rock, and move A from hard to soft. Okay, we can say from hard soil to the soft soil. Okay, you can see this is the soil factor, and this is the value of TB, TC, and TD given for every soil type. Okay, in Eurocode they have two types, which is type 1 and type 2. Type 2 is if the magnitude of surface wave is not greater than 5.5, so we consider the type 2 response spectrum, and then so we have to refer table 3.3 for every soil factor, every TB, TC, and TD. But if we consider the type 1, which the surface wave magnitude is greater than 5.5, we must refer to table 3.2 for the value of TB, TC, and TD. Okay, any question up to this level? Alright, no question. So in the Eurocode 8, this is the equation used to develop the elastic. Okay, this is for elastic response spectrum. We use the equation 3.2, 3.3 up to 3.5. And for design response spectrum, which is for design purpose, okay, you can find in the slide 43 in Eurocode PDF. We refer to equation 3.13, 3.14, 15, and 3.16 to develop the design response spectrum. Okay, so this is the the basic shape of design response spectrum. This one is for period, for the period of vibration 0 to TB. We use this equation, which is equation 3.113. For TB to TC, here we use equation 3.14. From TC to TD, we use equation 3.15, and from TD to T, we use equation 3.116. Okay, we have alpha G, we have S, we have Q, we have TC, and we have T. Okay, so this is the meaning of every abbreviations. This is the T is the vibration period of a linear single degree of freedom system. This is the alpha G. Alpha G we have to derive from this equation. Alpha GR we refer, okay, the value from seismic hazard map we discussed in part 1. This one is the value of importance factor proposed in clause 4.2.5 in Eurocode 8. Q is the behavior factor from clause 5.2.2.2. It's okay. We will discuss about the importance factor and the behavior factor later in topic 4, which is for seismic design. Okay, and this is the recommended value of S factor, salt factor, from Malaysia National Annex table NA1, page number 4. This is the value as recommended by a European committee, and this is Malaysia's decision. So as our project, if we got the project in Malaysia, so we have to follow this value. This is for Peninsula, this is for Sabah, this is for Sarawak. We still have 5 types of ground, which is A, B, C, D, and E. And this is the salt factor, and this one is the TB, TC, and TD recommended by the Malaysia National Annex. Any question up to this level? Okay, we can see the example of the design response spectrum. This one is developed based on the alpha GR equal to 0.12 G and salt type B, where the importance factor is 1.4. So we can see here that this one is for behavior factor Q 2.3, okay, the highest one, and then the lowest one is for Q 5.5. Okay, we can see the higher value of behavior factor tend to give smaller value of spectral acceleration at similar fundamental period of vibration. Let's say this is 0.4, the period of vibration 0.4. So if we use Q factor equal to 5.5, the spectral acceleration is here. And if we choose Q factor 2.3, the spectral acceleration is here. And for salt type D, the value is differ. As you can see, similar behavior factor, similar importance factor, similar alpha GR, but the value is differ due to different value of soil type. Okay, any question before we go to the exercise? Any question? Can we go to exercise? It's okay. I know you may be a bit confusing about the fundamental period of vibration, about the Q factor, about the alpha G, about the importance factor, and about the, source factor and so on. It's okay. We just go through by today, and in the next topic, we'll go through one by one. Sorry, I have to make this topic earlier because it will be more complicated if I put this topic later. So do you have your calculator with you? Okay, and do you have your Eurocode 8? It's okay, you can just refer to the notes. And do you have your national annex? Because we are going to refer the table. Ada tak national annex? Okay, so why not we go to the first exercise, this one. Okay, as in your notes. Determine the, this one. Okay, determine the magnitude of design spectrum based on the situation given. The reference peak ground acceleration is 0.12 G. The importance factor is 1.4. Fundamental period of vibration is given as 0.5 second. Soil type D. Response spectral type 1. So we have to refer to the Eurocode 8. Okay, we have to refer the Eurocode 8 table. The factor is given as 3.9 and the damping ratio is 5%. So you determine the value of spectral acceleration. So how to solve this question? First of all, we need to, example 2. Okay, first of all, we need to know the soil. Okay, so we extract. Okay, so it's better for me to get the solution to be here. So the soil is what? Soil D in Eurocode 8 type 1. Okay, so you bawa keluar anything related to soil type D. So you refer to this this table. So for type 1, so we refer to this table. Soil type D here, the S factor is 1.35. So we write down here S is 1.35. How about the TB, TC, and TD? Can anyone tell me what is the value of TB for soil type D? This one. What is the value of TB? This one, right? TB is 0.2, TC is 0.8, and TD is 2.0. So we just write down TB is 0.2 second, TC is 0.8 second, and TD is 2.0 second. Okay, boleh. Any question up to this level? Boleh faham Okay, and then what is the value given? The T1 given is 0.5 seconds. So here T1 is 0.5 second. So T1 is located between TB and TC because T1 is here. Okay, here. Okay, let's say here, this is your response spectrum. This is your TB. This is your TC. This is your TD. Your TB. One. So your T1 is 0.5 second. So let's say it's located here. Okay. So we refer back to our equations in Eurocode. If T1 is located between the TB and TC, so we use this equation, okay? Alpha G times S times 2.5 over Q. However, we have to determine the alpha G first, which is alpha G equal to gamma I times alpha GR. So this one, alpha G sama dengan gamma I times alpha GR. Berapa value gamma I? Given here as 1.4.
1.4.
Good, 1.4. Alpha GR is equal to okay, 1.4.
0.12.
1.4 times 0.12. So what is your answer? Please, somebody.
0.168.
0.168 unit. What is a unit? The unit is G. Okay. So by refer to these equations, okay, alpha G times S 2.5 over Q. Okay. Spectral accelerations at fundamental period of vibration is equal to alpha G times S times 2.5 over the Q. So just put in the value here. What is the value of S? The Saul factor?
1.35.
Okay, good. 1.35 times 2.5 over the Q. What is the value of Q given?
3.9.
Okay, good. The value is 3.9. Okay, somebody please.
3.9.
Zero point one four five. The unit is
Okay.
G, right? Okay, so G. So the answer here is 0.145 G. Okay? Okay, how about question number 2, exercise 2? I give you 5 minutes. Can you do it? If you have question, you can ask me. Okay? Okay, anybody finish? Anan dah siap ke? Wan Sunairah dah siap dah?
Saya dapat 0.192G.
0.192G. Okay, tadi saya letak 0.145. Yang ni. How about soalan 3? Ada yang dah mula soalan 3 tak? Exercise 3. Kalau dah siap, boleh buat yang exercise 3 terus. Dia masih sama, cuma yang berbeza ialah fundamental period of vibration, which is the T1. Yang lain tu masih sama. Soal type B, importance factor 1.4, masih lagi Q 3.9. Okay, I'll give you 5 more minutes. Okay kelas, boleh kita bincang soalan 1, exercise 2 and question exercise 3. Can we discuss? Okay. Okay, I need you to help me. For exercise 2, the value is still similar with exercise 1. Okay, the alpha GR is still 0.12 G. Okay, importance factor still 1.4. Salt type D, type 1 response spectra, behavior factor 3.9. The difference is only the increasing in fundamental period of vibrations. Okay, the new T1 is 1.12 second. So, which equation we have to use? Equation what? Because the T1 now is located beyond the TC. Okay, the TC is 0.8. So, T1 is greater than TC. Okay, T1 is greater than TC. However, it lower than TD. Okay, lower than 2.0 second. So, which equation we have to use? Anybody?
Three point 15.
Okay, so we use equation 3.15 because the T1 is greater than TC but lower than TD. So this is the equation as in the graph, this graph. So we can use these equations to solve our problems. Okay. Alpha G, is it still similar? Alpha G? I think it's still similar. Alpha G. We still can use the value. No difference. Okay, the salt type also similar, 1.35. So, SdT1 is equal to alpha G times S times 2.5 over Q, and then times TC over T1. Okay, this is T1. So, what is the value? Is 0.168 times 1.35 times 2.5 over 3.9 times, what is TC? What is
0.8.
0.8 over
1.1.
1.1. Okay, what is the answer?
1.10.
0.106.
0.106.
106.
Anybody? 6 unit is
G.
gram.
The
It's
G.
it's for gravity. Okay, that's why. Okay, ada sesiapa dapat nilai yang lain tak? Anybody got different answer? Syairah dapat nilai berapa? Sama je. Anis, Adlin, sama ke?
Sama rata.
Okay, how about question number 3? Okay, because our fundamental period of vibration is 2.3 second, okay, which is greater than 2.0 second here. Okay, this is our TD is 2.0 second, 2.0. So, for T1 greater than equal to TD, so which equation we have to use?
3.16.
Yes, we have to refer to equation 3.16. So by referring to this figure, so this is the equation. I just copy. Yeah, just bring it here. Okay, we still can use the value of alpha G. So alpha G, oh sorry, SDT1, okay. SDT1 is equal to alpha G times S times 2.5 over Q TC TD T1 to the power of 2. So 0.168 times 1.35 times 2.5 over 3.9. Okay, what is the value of TC?
0.8.
0.8 times
2.0.
0.0. Okay, divide by 2.3 to the power of 2. What is the answer?
0.044.
0.044 G. Okay, so this is the answer. Okay, how about the others? How about the others? Okay, similar answer, everybody?
Yes.
Okay, good. So we can see here, so we can have a sketch here at 0.5, okay, 0.5 G, 0.5 second. The first one, exercise number 1, so this is at 0.5 seconds. The acceleration, the spectral acceleration is 0.145 is here. Okay, and then at 1.1, right? 1.1 second, exercise number 2, it becomes lower, which is here. Okay, and 2.3, it becomes around here. Is 0.044. Okay, so you can see that the higher value, as the period of vibration increase, what happened to the spectral accelerations? Can somebody conclude to me? As the T1 increase, what happened to the SDT1? What happened? Anybody? Bila fundamental period of vibration ni semakin meningkat, apa jadi pada spectral accelerations ni? Dia meningkat atau menurun?
Menurun.
Yes, it decrease. Okay, so this one is one of the
Decrease.
so okay, this is one of our conclusion for today's lesson. Okay, this is the exact sketch. Okay, so thank you so much for your attentions, and I hope you can do more exercise. You just change, maybe you can change the soil type. Okay, from soil type D, you change to soil type A, or you change the value of alpha GR from 0.12, maybe you reduce or you increase the value of alpha GR, and you see what happened to the spectral accelerations. Okay, if you want to do your exercise, maybe you can just change this for exercise number 1. Okay, you can change the value here is maybe up to 0.16 G. Okay, and then similar to exercise number 2 and number 3. What happened if we increase the alpha GR? In your opinion, what happened if we increase the value of alpha GR? What happened in your opinion? What happened to the spectral acceleration? Is it increase or decrease?
Increase.
Increase. Okay. What happened if we lower down the alpha GR? What happened to the spectral accelerations?
Decrease.
Decrease. Okay. So how to relate this lesson is by referring to this map. Okay, by referring to this map, you can know what is the spectral acceleration near this area or and near this area. Okay, okay. I ask you one question. Okay, kalau kamu kita diberikan importance factor yang sama, behavior factor yang sama, soil type yang sama, let's say soil type D, in Nia and Cebu, which area will experience higher SDT1, higher spectral acceleration? Which area? Cebu or Nia?
Nia,
Nia. What is your justification? Because of what?
Nia.
because the alpha
Alpha GR.
Yes. Okay, good. Because the alpha GR in Nia is 9% of G compared to Cebu, maybe here 1, okay, 1.5, okay, 1.5 of percent of G. So Nia will experience higher seismicity. Okay, as well as here in Ranau is 16%, which is higher than the Pensiangan. Okay, I hope you can understand today's lesson. So thank you so much for your attention, and please do more exercise. You can change the fundamental period of vibration. You can change the soil type, and you can see what will happen to these spectral accelerations. Okay, so thank you very much for your attention, and thank you very much for your participations. See you again next class. Bye bye. Assalamualaikum.